Welcome to 4.4, Angle Properties. Okay, so if you remember, we only know the definition of one kind of angle, one kind of pair of angles, that's adjacent angles. That's what we learned in the last section. So we're going to talk about four other pairs. The first one is a linear pair. Okay, they're adjacent angles whose non-common sides form a straight angle. Or you could also say they were opposite rays. So in this sketch down here, point B would be the common vertex of ABD and DBC, right? And they share BD as a common ray, but this is a little bit different than just an adjacent angle because ABC is a straight angle and BC is a ray that goes in one direction and BA goes in the opposite direction. Vertical angles are adjacent to the same angle forming linear pairs with it. So, for example, ABD is a vertical angle with EBC. Another way to think of vertical angles is to think of them as non-adjacent angles formed by two intersecting lines. That's how I prefer to think of it. They're opposite each other from the intersection. So two angles that are complementary, you know this word from previous math classes. It just means the sum of their measures is 90, and then you have supplementary, which the angles sum up to 180. Now, I want you to pay special attention that the definitions of complementary and supplementary have nothing to do with them being adjacent. In fact, you could have a 12-degree angle in one place and a 78-degree angle in another place, and those two angles are complementary because they add up to 90. But they do not have to share a ray, they don't have to have a common vertex. Okay, so that would be the big difference, especially when we're talking about supplementary and linear pairs. Okay, supplementary means that just the two angles add up to 180. Linear pair means they are adjacent as well. Okay, so here's an example of complementary. We've got a 23-degree angle and a 67-degree angle, and together they are complementary. Again, I've got a 157 and a 23, and together they are supplementary. Okay, so all right angles are congruent. Hopefully that makes sense to you. 90 degrees equals 90 degrees. So here's a little sneak peek of our proof, and I want to go through this step by step. Okay, A and B are right angles, that's the given, and we're going to prove that angle A is congruent to angle B. So after I know that they're both right angles, I can say that the measure of angle A equals 90 and the measure of angle B equals 90. And why can I say that? That is officially the definition of a right angle. Now I can say that the measures are equal, right? If I substitute in the measure of angle B for the 90 degrees, I'm just doing a simple substitution there. Now if the measures are equal, then they are congruent. That is the definition of congruent angles. So really, this proof is too difficult, but it's just going to take some getting used to. Once we really dive into this, it'll start becoming a little bit more of a system. But I just want to, give you a little heads up here. Okay, so if two angles are adjacent and they are supplementary, then they form a linear pair. That's a little bit different than the definition, but I think I stressed that when we talked about the difference between supplementary and a linear pair. Another theorem is angles that form a linear pair are supplementary. Okay, obviously a straight angle is 180, so if you got two angles that make a 180, they're supplementary. If one angle of a linear pair is a right angle, then the other one has to be a right angle. Right then you're going to know I also have a perpendicular. That's what I told you when we would talk about a angle bisector of a of a line is going to be 90 degrees. Okay, so we have vertical angle theorem. This is going to be your new best friend and some proofs. It just says vertical angles are congruent. We don't even have to know the measure. We don't have to get our protractors out. We just have to know if we have intersecting lines that the vertical angles are congruent. Congruent supplementary angles are right angles. It seems like we've already covered this when we were talking about theorem 4.4, but it is just a little bit of a converse scenario here. So if they're congruent and they're supplementary, then they're right. Okay, so angle bisector theorem. If ray AB bisects angle CAD, then the measure of angle CAB is half the measure of angle CAD. So if you have a visual, I wish I would have remembered to draw a picture, but if you have an angle CAD and you put an array right in the middle, that means you have two halves of CAD. Okay, so for your WISC summary that you're going to submit to me, there are 5 practice problems. Following this slide, I'm not going to read them to you. I would like you to see if you can figure them out on your own. I am very confident that you can, and I will see you in class.